For our CL Lab 8, we will discuss assignment number 7, design and implement state model for a system. Aim to prepare a state model from the given problem description and draw a state diagram using element to notation. Implement the state model with a suitable object-oriented language. So, basically, this state model describes some aspects of object concerning time events that marks changes and states that define the context for events. Event represent external stimuli and state represent values of object. So, over time, the objects stimulate each other, resulting in a series of changes to their state. State model consists of multiple state diagrams, one state diagram for each class with important temporal behavior. State diagram must match on their interfaces, events and guard conditions. Each state diagram shows the state and event sequences permitted for one class of object. A state diagram specifies the possible states which transitions are allowed between states, what stimuli cause the transitions to occur, and what operations are executed in response to stimuli. State diagram describes the collective behavior for the objects in the class as each object has its own values and needs. So it's to each object has its own state or positions in the state diagram. First, identify the domain classes with significant states and note the states of each class. Then determine that the events that take an object from one state to another. Given the states that the events, you can build state diagram for the affected objects. Finally, evaluate the state diagrams to make sure that they are complete and correct. So following steps are performed while constructing a domain state model. Identify domain classes with the states. Find state, find events, build state diagram, evaluate state diagrams. Identify domain classes with the states. Examine the list of domain classes for those that have a distinct life cycle. Look for classes that can be categorized by a progressive history or that exhibit cyclic behavior. Identify the significant state in the life cycle of an object. Then a scientific paper for a journal goes from being written to under consideration to accepted or rejected. There can be some cycles. For example, if reviewer asks for revisions, but basically the life of the object is progressive. Finding state. List the state for each class. Characterize the objects in each class, attributes values that an object which may have the association that may participate in and their multiplicities, attributes and association that are meaningful only in certain states. Give each state a meaningful name. Avoid names that indicate how the state came about. Try to directly describe the states. Don't focus on fine distinction among states, particularly quantitative differences, such as small, medium, or large. State should be based on qualitative differences in behavior, attributes, or association. Then finding events. Once you have preliminary set of states, find the event that cause transition among states. Think about the stimuli that cause a state to change. You can regard an event as completing a do activity. If a technical paper is the state under consideration, then the state terminates when a decision on the paper is reached. In this case, the decisions can be positive, accept the paper, or negative, reject the paper. In cases of completing a do activity, other possibilities are often possible and may be added in the future. For example, conditionally accept with revisions. Note that the stage to which event applies. Add transition to show the change in the state caused by the occurrences of an event. When an object is in a particular state, if the event terminates a state, it is usually have a single transition from that state to another state. If an event initiates a target state, then consider possibility of using a transition on an enclosing state rather than adding a transition from each substate to the target state. If an event has different effects in different states, add transition for each state. Once you have specified the transition, consider the meaning of an event in states for which there is not transition on the event. Let us consider the example for ATM, where domain state model for the account class. So here you have account class state. What are the state? Normal, overdrawn, suspended, closed. Open account, withdraw excess funds for with overdrawn. From overdrawn state to normal state is deposit sufficient fund. For normal to suspended, the events are suspected fraud or release hold. From normal to the suspended, the actions are administrative actions, repeated incorrect PIN. And from normal to close, the event is close account. So each state models, what are the state connected? Pay particular attention to the path to it. If it represents a progressive class, there is a path from the initial state to the final state. Are the expected variation present? If it represents a cyclic class, in the main loop present. Are there any dead states that terminate the cycles? So use your knowledge of the domain for missing path. Exceptional flow also you need to consider. When a state model is complete, it should accurately represent the life cycle for the class. So we'll discuss the state machine diagram for ATM. So basically, the states are changed by events. State machines are useful to model reactive systems, which are defined by responding to external or internal events. It also describes the flow of control from one state to another. The states are defined as the conditions in which object exists, and it changes when some event is triggered. So the most important purpose of the state machines diagram is to model lifetime of an object from creation to termination. What is the main purpose? To model dynamic aspect of a system, model lifetime of reactive system, describe different states of an object during its lifetime, define state machines to model state of an object. What are the elements of the state diagram? State diagram consists of the behavioral elements. First is the state. You can show for a state by using a rectangle, and inside that a rounded rectangle. So the round corner rectangle with the name of the state written inside. So in this diagram, idle is the state written inside. The initial state and the final state denoted by filled black circle and labeled with a name. The final state is denoted by a circle with a dot inside and also labeled with a name. So here initial and final, you can see initial, there is a name written create, then alive is the state, and destroy is written on an arrow, and final is the circle with the dot. So initial and final state. Transitions are from one state to the next are denoted by lines with arrowheads. Transition may have a trigger, a guard, or an effect. So source state and target state denoted here, and trigger or a guard conditions you need to mention on a transition lines with arrowhead. So trigger is the cause of the transition, which could be a signal, an event, or a change in some condition or passage of a time. Guard is a condition which must be true in order for the trigger to cause the transition. Effect is an action which will be invoked directly on the objects that owns the state machine as a result of transition. So we need to specify the trigger, cause of transition, guard, the condition which must be true to execute trigger, and effect is the action which will be invoked by the object when particular guard condition is true. State actions are the transition example. If the target state had many transitions arriving at it, each transition had same effect associated with it. It would be better to associate the effect with the target state rather than the transitions. So this can be done by defining an entry action for the state. The diagram shows the entry action and exit action. So here for receiving state, two actions are defined: on entry pickup, on exit disconnect. We need to define the action inside state, entry and exit action. It is also possible to define actions that occur on events or actions that always occur. It is possible to define any number of actions of each type. What is the self transition? A state can have a transition that returns to itself, as in the following diagram. We can see that the waiting is the self transition after 2 seconds hold input. So it is the self transition we need to show with the line arrow connecting to the self. A state machine diagram may include submachines diagram, which is known as compound state. So here check pin has some submachine states like enter pin, and to check whether the pin is valid or invalid, checking actions. If pin is okay, then it finishes the check pin state and goes to the next state, search network or ready state, off state. So you can say this is the compound state diagram, state within state. So this is some alternative diagram: check pin, search network, ready, make a power on or off. So check pin we can show here when there is a compound state. Just check these two circle connected, this particular symbol used to show it is the composite state. The notation in above diagrams indicates that check pin is a submachine show. Entry point we can show at the normal initial state. Submachine diagrams normal to begin is the initializing state, but if for some reason it wasn't necessary to perform the initialization, it will be possible to begin directly with the ready state by transitioning to the named entry point. So instead of initializing state, we want to skip and start directly, skip initializing and connect it to ready state. So entry point we can initialize wherever we want. Exit point, we have alternative exit points. So the following diagram gives example where the state execute after main processing state depends on which route is used to transition out of the state. So here processing, reading instruction and processing instruction. So if from initial stage to writing error report, it is failed to read at this position, then displaying result will be continue, and exit point we need to mention here failed to read, and it can be exit at this particular state. Then the things that occur at a particular instance of time are known as events. All real systems are dynamic in nature, so it accepts the inputs and generate outputs, which means series of events and actions at a particular point of time. So for instance, in case of ATM machine, a customer initiates a transaction by pressing the button on the screen. Single thing of action occurred at a particular time instance is termed as an event. So event owns an activity or operations along with its time and location. So transformation of state and signal are asynchronous events while calls are synchronous events. Asynchronous events are the events that may occur in random time, and synchronous events depict the invocations of operations. Here, from idle to active are the events which comes under the signal active or event occurred. In order to imagine and understand event scenario, these events are broadly categorized into two types: internal event and external events. Internal events are communicated in between the objects which are situated inside the system. External events are communicated among the subsystem and its terms. So we represent events internally within state and externally on transitions. So signal events are the event which mean for description of a synchronous event communicated among instances. Signal can be considered a bundle of information that is communicated between instances asynchronously. A signal event is shown as stereotype class, the information which is to be communicated in between instances of a class. So here we can show it as a stereotype: successful transaction, signal, account number, type of account, amount, withdraw. Then for the operations, date of transaction and available balance. So signal event consists of the attributes as account number, type of account, amount withdraw, date of transaction and available balance. So signal can be directed as a message passing actions in an interaction. When we have a design particular element, object, class or interface, it is quite important to define the behavior of the element comprising of attributes, signal events and operations handled by that particular element. Signal sent is represented by convex pentagon containing signal name on its body, while signal received shown with the particular. So it is the signal sent and received. So when this arrow it is inserting into, it is the signal sent, and so rectangle which this kind of a lines is signal received. An event which depicts change or transformation in state after fulfillment of a certain condition is called change in a state event. So Boolean expressions and conditions, when date is equal to this, for better understanding we can make the change in a event. So idle and active condition, when date is equal to this, the change of state events occurs. Therefore, time event, there is specific time interval. So normally it represents with the help of keyword after and when. The keyword after states a threshold time after which an event is initiated and executed, and the keyword when specifies a particular instance of time at which an event is initiated. You should always make sure that the unit of time, hours, minutes, seconds, are noted in the diagram. So after 5 days, that is a passing time event. When 5:20 p.m. passing time event. So maybe it is after and when gives you the exact time. Change in the, this is known as a time event. Then choice pseudo state is shown in the diagram with one transition arriving and two more transitions leaving. So the following diagram shows whichever state is arrived at after a choice pseudo state is dependent on the message format selected during execution. So selecting message format, whether it is a voice message, text message, fax message, the choice pseudo state executed. Creating voice, creating SMS, creating facts. So this is indicated by the diamond. Junction pseudostate is used to chain together multiple transitions. A single junction can have one or more incoming or one or more outgoing transitions. A guard can be applied to each transition. Junctions are semantic free. A junction which splits an incoming transition into multiple outgoing transitions realizes a static conditional branch as opposed to choice pseudostate which realizes a dynamic conditional branch. So here you can check this is known as junction pseudo state. This particular darkened circle gives you the junction pseudo state, receiving all the messages at the junction pseudo state and replying from that junction state like a voice, SMS, fax. Terminate pseudostate action gives you enter. Pseudostate indicates that lifeline of the state machines has ended. Terminate pseudostate is noted as a cross. If you want to terminate pseudostate, running power of make a terminate action by putting a cross. It is known as terminate pseudostate. Then a state may be divided into regions containing substates that exist and execute concurrently. The example is applying for the brakes in the front and rear brakes. It will be operating simultaneously and independently. So use of for can join pseudostate rather than choice and merge pseudostate. So these symbols are used to synchronize concurrent threads. We need to put a dotted line within the state rectangle to indicate these are the concurrent regions. Applying brake is the state. For front, applying front brakes. For rear, applying rear brakes. But these are the concurrent activity denoted by dotted lines to show the two concurrent regions, front and rear regions. Well, let's discuss one example of ATM is mentioned in the manual, but for implementation we are considering again the online grocery shopping system for drawing state diagram. Example of ATM system, what are the state? The states changes from idle to serving customer when the customer insert banking or credit card in ATM card reader. On entering the serving customer state, the entry actions read card is performed. The transition from serving customer state back to the idle state will be triggered by the cancel event as the customer could cancel transaction at many times. So this is the example of the state machine bank ATM. There will be the states first is off. It is connected to turn off or shut down from the idle state. Then self-test is for maintenance. It again goes with the service and out of service. After failure, it goes to the out of service. Then for serving customer state, when it is inserted by a card, it goes from idle to serving customer state. So entry, read card and exit, eject card. Customer authentication is composite state again. Select transaction. Transaction also is a composite state which consists of other substate. So this is the state machine example given. So we can also implement the state model within the by using Java. So this is related to the theoretical aspect of how to draw state model. Then we will go with the implementation in star UML. Already we have Now we consider for drawing our state model for online grocery system. Already we have drawn the sequence diagram for the same, class diagram for the same. Now for drawing the state diagram, we will go first to the online grocery system, which is located to the right hand side. Right click and say add diagram and click on state chart diagram. You will get all the state symbols here. Then start drawing the diagram. Take the state diagram name as online grocery shop GS. You can give any name. For drawing the diagram, first we need to draw initial state. Click on this initial state symbol, put it here. After that, define a state idle. As we need to define a state like idle, login, then shopping delivery, a selection of a product, placing an order. These are the states related to the online grocery shopping. So for idle state 2, the next state is login. We need to define this as a login state. For showing the login state, we need to add some of the substate of login. So define that sub machine state inside the login. So give the name of sub machine state like first is the login, then register, put the sub machine state as a register for particular website, then user authentication. So put the submachine state as a user authentication. So first login, then user authentication and the registration event. What are the connections? The transition from login to user authentications we need to put. It indicates that user authentication. After that, from register user to the new user we need to put the transition from register to the login. So here after registration you can make the login to the system. So registration is there. You can put the login to user authentication. So this is the login details. If you want to make the final step inside, you can put user authentication. After user authentication, it should end inside the login. Then if you want to make the self transition, put here to the login, which is nothing but invalid credential. So for invalid credentials, you need to put the self transition. Okay, connect. Then connect from initial state to idle, then from idle to login. You can make the connections. After that, after login, there is a selection of product. You can make it as a state product selection. Inside the product selection, again make these as a composite state. It consists of the concurrent activity, product selection machine state may have some of the concurrent activities. So you can put some of the synchronization here. So you can put the synchronization between these two for showing the concurrent activity. So first is what are the two steps buy now and buy later. So we need to specify the submachine state, view product first, view product. After that it connected to the next state, select quantity. Then next method is add to cart. You can select view product, select quantity, add to cart, which are the different transition state and connect. After this, parallelly we can show the submachine state like view product, add to wish list. That buying is not possible at this moment. You can connect to this and you can make the end also, like make a final state here inside the product selections, and you can connect that add to wish list transition from this, and starting point again from this. If you want to define the initial state also, you can define it. That is from starting to product. Two parallel actions can also mention here. View product. These are the parallel activity of product selection. From login to product selection, you can make the one more transition. After product selections, there is a placing of order and delivery. You can click one of the states like delivery. You can make inside delivery state, receive order as a submachine state, receive, receive, receive order. Then replace order or return order. If I want to select the choice point here, select two options, replace, replace order and receive order. Return order, not receive, return order. Three conditions, three states are possible for the delivery: receiving of order, returning of order, replacing of order. So we can connect this with the transitions. From this you can connect with the transition or the deliveries. This is your delivery, and if you want to end the state here, make it as a final state and connect your all transitions. You can connect all transitions to this. Delivery. Then the last step for this is the placing order state, placing order, for which the substates are to start with the initial state like avail discount. Okay. Discount state can be there, then view total for placing order, total payment selection and price must be accessible. After that, you can see shipping details or shipping address should be finalized. Then choose payment option. Particular payment option must be choose payment. Now you can define a payment as a separate state. And you can end or you can connect from initial state to each of the state. Discount to total, from total to shipping, and from shipping to payment. In this order. And you can make the final state here after receiving the payment, and then you can select transitions from the product selections to placing order. And then last state you can define as a logout, from login to logout state, and this will end your all the state that goes into your final state. This is your logout is your final state. You can define the transitions. After that, you can check here if there is a order placement field. You can put as a self transition. You can repeat that particular order. So self transition for this, you can placing order, draw self transition here, and mention that order placement field. You can repeat or change the transition. For logout also, you mention after placing order, you are connecting to the logout, and after placing order, try to connect transition from placing order to delivery state. So make a transition from placing order to delivery state. You can connect here to the delivery state, or if you want, you can connect from here. Connect the transition from here. from placing to delivery. So we can connect the placing order to the delivery state. So this is all about your state diagram. Identity login state, from login to product selection to placing order, and after placing order you can go to the delivery state. So this will indicate your whole state diagram. Now there is an implementation for the same. For this, first you just click on the tools Java generate code, you will get its implementation. So select a starting package location. So here online grocery system already we have defined inside our model. So here we are generating all the classes for Java code. So we are not generating with this particular element, so we are deselecting it. We can create the as per the new model. So basically check whether to select the Java code for it. Then for the state model, you can generate some code which is available directly from the output directory. You can select the code directory and you will get the code which you specified on a particular site. So you can generate the Java code successfully for the model also. So this is the implementation of the sequence diagram for online grocery system. You need to define your own different diagrams like sequence, use case, activity, state chart for a given system, and try to use the concurrent region, then pseudo state, the junction point, composite submachine state. So this is regarding your state chart diagram.